In this experiment, we want to study the variation of the current in a series RC circuit fed by square wave voltage. So here we have a resistor of resistance 1 kilo ohm connected in series with a capacitor of capacitance 100 nanofarads. The resistor and the capacitor are connected in series with a function generator. Observe, the function generator is adjusted to provide square wave voltage. Now we want to display the voltage across the function generator and across the resistor on the screen of the oscilloscope. So I will connect the channel 1 across the resistor and channel 2 across the function generator. Now the ground terminal of the oscilloscope is electrically common with its metal chassis, so we don't need to connect the ground of channel 2. Now observe the curves on the screen of the oscilloscope. I will displace the curve of the voltage across the resistor to the bottom of the screen. Okay, now during a first half period, the voltage provided by the function generator is maximum. This is the charging phase of the capacitor. During this time, the voltage across the resistor decreases to 0, but we want to study the variation of the current. The voltage across the resistor is equal to the resistance of the resistor multiplied by the current it carries. For an ideal resistor, the resistance is a positive constant, so the curve of I is similar to the curve of the voltage across the resistor, differing only by a constant multiplying factor. So here, when we say the voltage across the resistor decreases during the charging phase, then the current decreases to 0 during the charging phase. When the current becomes 0 at the end of the charging phase, we say that steady state is attained. Now, during a second half period, the voltage provided by the function generator is 0. During this time, this is the discharging phase of the capacitor. During this time, the absolute value of the current decreases to 0. And when the current becomes 0, again, we say that steady state is attained. Now, another important remark. Look at the curves of UR in the charging and the discharging phases. They have opposite signs, which means that the charge current and the discharge current have opposite signs. We conclude that the direction of the charge current is opposite to the direction of the discharge current.